know it. You still got it. Okay, 3, 2, 1.
Lights, camera, fractions!
Okay. Okay. So what we're going to talk about today, in the past, or the last couple days, we talked about graphing, right? And we talked about using a T-chart and so forth. Today, I'm going to be teaching, it's the beginning of my teaching you shortcuts to graphing. Where the first one some of you know, but most of you don't. And before I actually get there, I want to talk about, what we've been talking about so far are straight lines, equations that give you a straight line, right? All right? And there are 3 useful ways to write equations with straight lines. And somehow, you guys have to memorize these. And I'm going to put a challenge out to you guys, because historically, everybody has trouble memorizing this. And it's not hard, and it's outrageously useful if you know not only the formula, but what the formula is called. Really, really useful. Because immediately, if you know both, you know exactly, when you see this formula, say, oh, well, I know that's got a point and a slope in it. Where's my point? Where's my slope? Or if you see this one, you say, oh, I know I'm going to have to solve that with my x and y intercepts. Oh, that. Oh, yes, I have a point. I have a slope and a y-intercept, right? To know those things, that's in the name. It's not in the formula, right? So to know both is really good. So my challenge for you is to figure out a way, either a poem or whatever. I'll give you extra credit. I will give you outrageous extra credit, right? If you did this, if you could figure out a way that would help people memorize this, because for some reason, some people struggle with it.
What if we came up with a new way to do it? What if we came up with the 4th way? Would you just let us know?
Well, there's probably thousands of ways, right? You could write equations in lots of different ways. But these are 3 useful ways that are pretty common that you'll see in textbooks and so forth, okay? Okay, so guys, your conversations. Right? So, first way. It's called the slope-intercept form. And the equation is y equals mx plus b. Very, very famous formula. Outrageously famous formula. Very, very useful formula in real life. Yes?
What are the variables?
So everything in here, all these variables stand for something.
Yeah.
And when you actually have a real equation, it would look like this. The y and the x would stay as variables. But the m and the b would become numbers. So it would be like y is equal to 2x plus 4. See what I'm saying? So you still have your y and your x, but your m is your 2 and your b is your 4. That's an example. Yes, Jan. Statement? I'll call on you in a minute. Let me just do these things first, okay? Let me just say the 3 different ones. The second one is called standard form. And that would be like this. ax plus by equals c, where a, b, and c are actual numbers. So an example, that last graphing problem that we did on the homework, 2x plus 3y equals 12. That's an example. You still have your x and your y, right? You're going to have your x and y in all of these, right? And then everything else will be numbers. But notice that x and y are standing on the left side of the equal sign. Do you guys see that? Here's the equal sign, and these are both standing on the left side. Here, that's not true. Y is on the left, x is on the right of the equal sign. These are standing on the left. So we call it standard form. It's a good try, right? It's a good way to remember, right? And then the third useful way of writing straight line equations is called point-slope form. This one looks really, really scary when you see it. And it's really, really easy and really, really useful once you understand it. That'll be maybe a week or two down the road. But it's y minus y sub 1 is equal to m parenthesis x minus x sub 1. Okay? All of those you have to memorize.
Okay.
And if you saw this as an equation with, an actual equation with numbers, the m, the y sub 1 is a number, the m is a number, and the x sub 1 is a number. So it would be like y minus 2 is equal to 1/2 x minus 4. Something like that. Okay?
Oh, when you put real numbers in, it's like less scary. Or when
Yes,
you put real
exactly.
numbers
It's
in.
less scary when you actually have the real numbers. Same with this, right? That's much more fun to
Oh,
look at than that.
that wasn't really that bad.
Okay. Very useful, all three of them. They all have a very useful place in math. So
Oh,
today, though, and I'm going to be teaching you shortcuts on how to graph all of these. If you can't remember the shortcut, how can you graph them?
The t-shirt.
With a T-chart. A T-chart works for everything, right?
Oh, sweet.
You knew, even though I didn't teach you this form, last night you were able to use a T-chart and graph it, right? I don't have to teach you a new form or a shortcut. You could use a T-chart on this. It might take a little computation, but you could do it. So now we're going to talk about the shortcut for this first one. So I'm going to erase this, the second and third, and this is what we're going to focus on. And I'm going to call on Jan to help me for a second. But it says y is equal to mx plus b. All right. We know x and y are our unknowns, right? Those are the things that we would be, we would, if x is this, y is that. If x is this, y is that. You'd use your, you could use your T-chart. But what is b? What is m? So, Jan, what's m?
Okay, so I call it the rise over run, or it's the slope.
So m, the m is the slope. And slope is rise, it's a fraction. Rise over run. That is a fraction, okay? Make sure you guys get this, it's really important. Slope is rise over run. Remember, you know how I've told you that a lot of times it's helpful in algebra not to convert your fraction to a decimal or to something else? This is why. Slopes, you want slopes to be fractions. If they're not fractions, you got to make them into fractions. You don't want it to be not a fraction, right? If it's a whole number, you have to put it over 1, so you've got a fraction. So you understand what that is. And we're going to talk about that in a second. But what is this one? What is the b?
The B is the Y-intercept.
Yes. So the b, right? The b is the y-intercept. Now we're going to talk about what these mean. Okay? So if I have a graph, and I said, this is my y-axis, and this is my x-axis, okay? And some of you may have never graphed with something like this. Don't worry about it. It's not that big a deal. You just have, it's a cross, right? And the vertical line is your y-axis. I'll even put the word axis. And the horizontal is your x-axis, okay? And you have, let's say I was asking you, well, let's see. Hold on. Let's say you have a line like that, okay? And it goes right through that point right there. Is that on the y-axis?
Yes.
Oh, so that is called my y-intercept. It intercepts the y-axis. Right there, that point is called the y-intercept. Right? So you guys, a lot of you have at least watched football,
Yeah.
right? You know what an interception is? I'm passing it to Mushi, and because he was trying to calculate everything in his head, he forgot to catch the ball. And so Basie from the other team jumps over and he intercepts the ball, right? Right? And so that's intercept. So basically the y-intercept, why would they use B and M, right? I don't know. I call it like a bump. It's a bump on the y-axis, right? Think of that as where the line bumps into the y-axis. And m, I just like slope, slope. Doesn't work. Doesn't work for me. So I just think of like mountain slope, right? When you're skiing down the mountain, there's a slope, right? If you don't have a slope, it's not a very fun experience, right? Right? You're just standing there without a slope. You need the slope in order to move, right? So, so M stands for slope. B is your y-intercept. Now, Jan said that slope is rise over run. So this is very cool. Let's actually practice graphing one. Let's say I said graph this. Y is equal to 1/2 x plus 3. 1/2 x plus 3. So draw a graph, okay, on your notes, and put like 5, go up like 1, 2, 3, 4, 5, 6 things up there, and then 1, 2, 3, 4, 5 there. We'll just keep it all positive right now.
Simple.
Okay? Okay? And ideally, try to make them as even as you can when you do that.
I tried.
All right. So when you're graphing with the slope-intercept form, and you're trying to do it the shortcut method, the very first thing is you graph the y-intercept. Right? So what is the y-intercept? Wait.
Positive 3.
Y-intercept is your B. It's the thing on the far right. So it's your positive 3. So that is where it bumps into the y-axis. So that is actually a point. On the y-axis, all I have to do is go to 3. You with me? And I put a dot. So this is my y-axis. I go 1, 2, 3, and I put a dot. Okay? So we're going to be practicing this. Are you guys paying attention? Because we're going to be doing this. Okay, I just want to be sure. So up at 3, we just plotted that. So that's the first thing you do. You take the last number and you put it on the y-axis, wherever it is. If that had said -4, I would have gone down 1, 2, 3, 4, down below and put a dot. Right? If it said +12, I'd have to go up to 12. Right? But it's always going to be on that vertical y-axis. Now, I take my pen and I put it on that dot. Right? And it says my slope is what? My slope is the number in front of the x. Whoops. My slope is the number in front of the x, which is what? 1/2. And Jan said slope is rise over run. So when you rise up. And when you run, you always run to the right. Okay? Always run to the right. In fact, that's so important, I'm going to put this right. Right. Right? But rise, you go up if it's positive. But what if it was negative? You would go down. A negative rise would mean fall, right? But you still run to the right. Always run to the right. The only thing that changes with positive and negative is up or down. Okay? So right now, it's a positive. So I'm going to rise 1, and I am going to run 2. So from this dot, I am going to rise 1,
X-axis first.
and I'm going to, what?
You have to go X-axis first.
No, you run.
No, get out of here. Get out of here, buddy. Mushy, you're thinking too much in your head. Stop, okay? Right.
Calm down.
Stop
Right.
thinking.
So here we go. So from 3, you're going to rise 1. I'm going to rise 1, and I'm going to run 2. Now I run 1, run 2. See, there's my 2, right? And I put a dot there. Now, the beauty of slope of a straight line is that no matter where you are on the line, that slope continues. So I could rise 1 and run 2 again. I'm going to rise 1, run 2 again. 1, 2. Put a dot. I'm going to rise 1, run 2. Put a dot. rise 1, run 2. I could do this all day.
Run 2 and then rise 1.
It makes a rectangle.
And so what we're going to do, then you connect your dots and you have a straight line and you put an arrow on the end of your line. Now, do you have to do the slope more than once? No. You could just do it once, you could do it twice, you could do it 3 times. There are times that it's useful to do it many times. But for graphing today, I'm fine with just doing rise 1, rise 1, run 2, and then that's good enough. Right, you could do that too. So the only trouble with the run 2, and rise 1 is what's going to happen is most people when they see a fraction, they always start with the numerator, right? So I don't want you to get confused. If you start saying run 2, rise 1, you're going to end up doing it. It isn't. I mean, it is, but it isn't because you're starting with the denominator. And most people, when they see a fraction, when they talk about a fraction, they talk about the numerator first. Like 1/2. You don't say 2 under 1. You say 1/2, right? So I just want to make sure you know the first number is a rise. The top number is a rise. The bottom number is a run. Just be aware of that. If you wanted to think of it differently in your head, that's fine. But probably don't try to encourage too many people to do that right now. It'll get confusing. So does everybody see how we did that? So let's try a few. Let's just try a few and make sure that we have this idea down. So here we go. Here's our graph. And I have y is equal to 2/3 x plus 1. All right, I didn't say what the second step was. Okay, so the first step is I graph my y-intercept, which is what?
1.
It's the 1. It's the last number, right? I'm going to graph that. It's a positive 1, and it's on the y-axis. It's where this line will bump into the y-axis. And it's going to bump right there at 1, right? From there, I'm going to rise what? 2. Rise 2 and run 3. So I'm going to rise 2, rise 1, rise 2, run 1, 2, 3. Put a dot. I'll do one more. Rise 1, 2, run 1, 2, 3, put a dot. And then I draw my line. And I put arrows on the end of it, and I'm done. Isn't that cool?
Yeah, that's cool.
This is totally new in math. Never learned that before, Gary. You only have to
Well, it's weird because this is the first time that math group has ever known this.
Yeah, because we got.
Because you got it advanced? Okay. This is the first time you guys have known that.
Yeah, we smart.
Which is awesome because it is the most useful way to graph. All right, now I'm going to make it harder now.
Oh no. Great, I thought it was
Y is equal to 1/3 x minus 5.
Oh.
So the only thing I did differently,
It's a negative y. It being
so where would I put it on the y-axis?
The negative 5.
Negative 5. That last number is negative 5. So from here, I'm going to go down 1, 2, 3, 4, 5. Right there, I'm going to put a dot. And then I'm going to rise 1, and because this is rise 1 and run 3. So from here, I'm going to rise 1, run 1, 2, 3, put a dot. Rise 1, run 1, 2, 3, put a dot, draw my line, and I've done it.
Cool.
You can do this in 4 seconds. I mean, it's really that fast. So what the homework I have given my class in the last 2 nights for graphing these, that you had to do the T-chart. It might have taken some of you, 10 minutes. It might have taken some of you 30 minutes. Figure if there are 6 on one side, 6 times, say 5 seconds, that's like 30 seconds, right? 30 seconds on the first side, 30 seconds on the second side. Takes about 1 to 2 minutes to do the homework. It's kind of nice, right? Okay. So anyways, okay. Now, everybody clear? Fist of 5. I just want to see where we're at. All right, now I'm going to make it harder. One step harder now.
Why?
Here we go. Y is equal to negative 1/2 x plus
Oh, wow.
plus 4. Plus 4. I know you guys know how to do it. I want to try somebody else. Okay, Luke. So wait, let's have it quiet. Basie, Rico.
So on the graph for the y-axis, you go up 4 and put the dot.
Yes. So I start here. I go up 4. 1, 2, 3, 4. I put a dot. I did this first.
Yeah, and then would you go down 1?
Yes. It's the negative. Notice where the negative is.
And then go to the right 2?
So those 3 people right, I mean like Risa and Irene and Jade, are you guys listening? Are you looking at this or are you doing something else? If I came over there and look at that, would it be this? Is that notes of this? I didn't think so. So why don't you put it away? Because I'm asking you guys to focus on this. Have you been taking notes, Jade? Okay. All right. So that negative sign is in front of the fraction. The negative sign is in front of the fraction. When I'm teaching, guys, just so you know, when you guys are talking and I'm teaching, it's very disrespectful, and I feel like I'm going to then have to re-teach the whole thing again. It's not fair to me. I don't want to teach this 3 times, 4 times, 5 times. I want to teach it once. That's why when I'm lecturing, I like you to be quiet, unless I'm inviting participation. But for you guys to turn sideways and start talking to people and writing notes and drawing things, that's not helpful, right? Is that clear? All right, so that negative sign is in front of the fraction. When you have a negative sign with a fraction, think of it with the numerator. All right? So really in my brain, this is what I'm doing. I'm putting the negative sign in front of the 1. I'm not necessarily doing it on paper, but I'm... Hopefully...
Goodbye,
Please
camera.
kill you. So working.
Hopefully...
Wait, is that
That's the camera.
it fell off of the...
Is it still recording?
Yeah, you guys tend to kick the camera a lot. All right, let's try that. Hopefully that works. So now when it's rise over run. So the rise is negative. So what would that be? It would go down, right? So from this dot at 4, I'm going to do a negative rise, or basically a fall. Fall 1 and I run 2. Dot. Fall 1, run 2, dot. Draw my line. Okay? So when the slope is negative, it's always going down to the right. Always. When the slope is negative, it's always going down to the right. When the slope is positive, it's always going up to the right. Right? This is called a positive correlation. This is called a negative correlation. Negative correlation, negative slope. Positive correlation, positive slope. Okay? So a lot of times I can instantly tell people have graphed it wrong because they have the slope going in the wrong direction, right? So, all right, so that's basically it, and we're running out of time. Yes?
I have 2 questions.
Yes?
Is it possible that the denominator would be negative? The denominator is negative, but it always goes right. Yeah, no matter the whole fraction.
With a fraction, with a fraction that's negative, you can have negative 1/2. That's the same as negative 1 over positive 2, or that's the same as positive 1 over negative 2. That fraction, if it has 1 negative sign in it, it's only 1 negative, no matter where you put it. If you had 2, then that fraction would be positive, because a negative divided by a negative is a positive, right? So I didn't finish this. The second thing was use rise over run, right? All right, that was your second thing. And I think that's all I have to do.
Homework.
Okay, I'm gonna just give the homework.